60 whatevers, I get 360 total. That's where it comes from. It is manufactured based upon this belief of the importance of one, equilateral triangles and the number 60. Obviously, at least in my presentation of it, it's man-made. The mathematicians wanted to get away from all the man-made stuff. They wanted to come up with what is the purest form of all of mathematics so that we can eliminate as much human influence as possible. And so they decided to come up with something that is true for all circles. So they take a circle, and all circles have what?
A center.
Okay, and?
A curve.
Okay. Euclidean space here.
A diameter.
Okay, or I'm going to narrow that down, radius. All right, they all have a diameter, they all have a radius, which is just half the diameter. So all circles have these two things in common. And so mathematicians said, well, suppose we take this r here, this distance, and we just imagine that's a piece of string. Let's wrap that string around. And they found out that for every circle, no matter what the radius is if that arc length is the same as the radius, this angle right here is the same. And that's what they said is 1 radian. Matter of fact, we can take a look at one other thing. This angle here we'll just label as theta, and this is the arc length we'll just label as an s. No matter if my arc length is 2 radii, my angle is 2 radians. If it's 3, it's 3 radians. If I go all the way around the circle, I can put 2 pi radiuses, try that one again. I get 2 pi radii all the way around, so therefore a circle is 2 pi radians. We can write this mathematically. Arc length is equal to the radius times the angle in radians. This is going to connect back to units here in just a second. So if I have a circle of radius 4 meters, and then I have an arc length of 10 meters, what is the angle that is subtended? Oh, we're going to go for stunning visual effects here. Ooh. So if this radius is 4 meters and my arc length here is 10 meters, what is that angle?
4 meters. 4 meters. 4.
You said 4 meters?
Is it the same?
No.
Maybe like 10 over 4? It's like 10 over 4?
It's like 10 over 4?
Yeah, would it be? Like if you do it in an equation.
How'd you get 10 over 4?
I put the 10 meters for S, and then it will equal 4 meters theta. And then you would divide off the 4 meters with the 10 meters, and then the meters would cancel, and then it'll be 10 over 4.
Okay. Or for the decimal
Or,
phase,
yeah.
2.5. Not only is it like 10 over 4, it is. But units cancel out here, but didn't I say that the angle would be in radians?
Mm-hmm. So then you would have to do the conversion.
No.
No.
No, sorry, what conversion are you talking about?
Or you take the, I guess the degrees and convert it
We
to-
don't have any degrees up here.
Okay. Okay, then.
We could, but
Yeah.
we're just gonna end up back where we started. What happened to my radians? Unit should work out.
Oh, it's just radians.
Just throw it in there, just for fun?
It's just, I mean, wouldn't it already just be 2.5? Oh wait, no, so that would be. Well, no, theta is in radians,
Yeah.
so that means 2.5 is in radians.
So I should just write it down?
Yeah.
The meters cancel out and just the vacuum nature of course is a vacuum, so I just throw radians into it? Is that what you're saying?
Is what I'm saying.
Okay. Suppose I just wrote down 2.5.
2.5 what?
Just 2.5. If I wrote down 2.5 as I originally wrote, is this wrong?
Yeah.
All right, like 2 yeses and 1 no, and fight. And I don't know.
Well, okay, so you have the arrow pointing to theta and it says in radians.
Correct.
So when you do 2.5 equals theta, that theta's already radians. So wouldn't that equal 2.5 theta, which is already in radians?
All right, so if that's in meters, so if S is in meters, just doing a unit analysis like we did over there, and R is in meters, and theta is in radians, meters equals meter radians?
What, you,
I got a no over here.
What?
wouldn't you divide off the meter?
Okay, divide off the meters, and I got 1 is equal to radian.
So that's just, 1 is just 1 though. So
Yeah, it's just 1.
Oh, so I can't throw in the radians on there?
Well, I haven't said that.
Okay. Okay, so then we can throw in the radians.
Yes, we can. Radians is a unitless unit.
Okay.
2.5 actually is correct. 2.5 radians is also correct. I had a student a number of years ago, since radians really is the equivalent to 1, just would tack radians onto every answer, just for fun. That's what he enjoyed, why not? It's not technically wrong. So why on earth do we have this unit of radians when we don't actually have to write it? For clarity. If I said the angle was 40, I think most people would wonder, all right, does he mean degrees or is he talking about radians? Most people within this context, I'm not talking about the general population. So you put down radians when you want to make it clear, and you don't put down radians if you don't want to. So that's the deal with radians. Back to trig. Oh, questions at this point before I continue to erase? Oh. All right, so let's talk about tomorrow. Any questions? I don't think I gave enough time there. All right. I'm used to an hour and 20-minute classes, and I think they're now hour and 15 again, so apologies for that. The lab, you need to do the course entry assignment at least one submission in order for the coursework in the lab and all that stuff to show up. In labs, the first lab is non-measurement and uncertainty, measurement and significant figures, something like that. When you come in tomorrow, since tomorrow is lab day, I would like you to have that printed out before you come in. If you got printer issues, then we'll deal with that when we get there. But
So you have print out the lab?
print out the lab. It should have tomorrow's date on it. I hope it says 8/16. Anyway, glad you're all here. I'm also glad this is a 16-week class instead of an 8-week class. I hope that was your preference. And I'm also glad this is face-to-face and not online. So a whole lot of things I'm looking forward to here. Have a wonderful day. And I'll leave. Do you have a moment? Do you have a moment to talk? Okay.